Bismillahirrahmanirrahim. I am Professor Jamil and you are watching YouTube channel. Today we are going to have a problem on Laplace transform, which is unusual in the sense because it is not found commonly in the books or in the class lectures. And you go for the problem. You need to find the Laplace transform of iota exponentiated to iota, exponentiated further to the variable t. So this is a function of t. As t varies, this value varies. So this is the function of t in a very typical form, and you need to find its Laplace transform. Now you have got iota here, and let's check. Here is its answer. The iota can be written as 0 plus 1 into iota. This is the Cartesian form of the complex number. X plus iota y. X is 0 and y is 1. Now you can turn it into polar form and it becomes cosine of pi by 2 plus this iota. Okay. Plus this one is sine of pi by 2 into I, right? Now, cosine function is a periodic function of period 2 pi, which means 2 pi, 4 pi, 6 pi, 8 pi, if added or subtracted from the argument pi by 2, would make no change in the value of cosine function. Similar reasoning for this. So this formula can be written in more general form as cos of pi by 2 plus 2n pi plus this iota into sine of pi by 2 plus 2n pi, where n is integer, 0 plus minus 1 plus minus 2 plus minus 3 dot, right? So you can write iota in this typical form. Now cos theta plus iota sine theta, this can be turned into an exponential by virtue of Euler's formula. So you can write this iota equal to this cos theta. This is cos theta plus iota sine, and this is theta, and this is e to the power iota into theta, and theta is this thing, pi by 2 plus 2n pi. I would suggest you should remember this result also. This is a very elegant result and frequently used in physics and other scientific calculations. That iota is equal to e to the power iota pi by 2 plus 2n pi. Now, you see, this iota can be turned into an exponential. And the Laplace transform of the exponential, right? So, by using this result here, we will transform our function this iota power t into an exponential function, and then finding the Laplace transform of exponential is a one-step question, because the Laplace transform of, for example, e to the power kt, and this is equal to 1 over s minus k, where s is greater than k. So once you have the function in your exponential form, you will solve the question in one line, right? So come here, from here, move into this side, iota power t, and this is in fact iota exponent t and exponent t, and write the values. This iota is e to the power, this one, iota into pi by 2 plus 2n pi, and then this bracket, and you have I, one more bracket, and you have t. Now exponent multiplies with the exponent, right? So multiply these two exponents, you have iota into iota, this is iota into iota pi by 2 plus 2n pi, and then there is the exponent t, and this is e to the power, this is iota square minus pi by 2 plus 2n pi, and this exponent will also be multiplied with this exponent. So iota exponent t is equal to this exponential function. And now take its Laplace transform. And let's take the Laplace transform here. Here I take it. I may take it here. A bigger space. And you may name this equation as equation number 1, in which you found the value of iota equal to this one. So now you have used this value iota, and take the Laplace transform. Take Laplace transform. So here you go for the Laplace transform. Laplace transform of iota exponent t is equal to Laplace transform of e to the power minus pi by 2 plus 2n pi into t, right? And using Laplace transform of e to the power kt equal to 1 over s minus k, where s is greater than k, we get. So here is your answer now. Iota t equal to 1 over s minus k. In place of k you have this value, exponent of t, all these. In fact, you can use, if here is a plus sign, you have minus, and there is a minus sign, you will have plus sign here. So you have minus sign, you will get plus sign in the answer. So this is pi by 2 plus 2n pi, where s is greater than pi by 2 plus 2n pi. So this is the Laplace transform of a very different looking function, iota, exponentiated iota, further exponentiated iota. I hope you enjoyed this solution. Keep watching, and please like, share and subscribe this channel for such interesting videos. Thanks for watching.